Woohoo! Welcome back. Today we're going to be doing one-sided limits to work with a piecewise defined function. Woohoo! Yay! Let's hear it for us. And what I'm going to recommend is the first thing we do whenever we're trying to figure out limits is to go ahead and try to graph the function just to see what the heck is going on. We've got this function, which as long as x is greater than or equal to 2 is equal to x, which is a nice, easy one to graph. Now, this is going to be a little trickier to graph. This is going to be a square root or a radical. And if x is less than 2, so that means it could be 1.9 or 1 or 0 or negative numbers, then we're going to have this square root, which is going to be kind of weird looking. So what we might want to do to graph it is to actually set a table of values. So that's what I'm going to recommend. So table of values, where I've got x and f of x. And as long as x is greater than or equal to 2, so if x is 2, f of x is 2. If x is 3, f of x is 3, 4, and 4, so on. So this whole section here, I'm going to call the blue piece right there. That goes along with this piece right there. So that part is not going to be hard to graph, I think. That part, let's see if I can make it, hopefully make it look easy and not just make it look hard. This is going to look like starting at 2, I've got 2, and then at 3, it's going to be 3, and at 4, it's going to be 4. So I've got this function that goes up, this graph that goes up at a 45-degree angle from the horizontal, that is. And so that is our second half of the graph. So life is good. Now, the first half of the graph over here, I know it's going to look something like a square root, right? So that's going to look like a parabola. And I've got 2 minus x inside when x is less than 2. So let's look at what happens. When x is 1, 2 minus x would be radical 2 minus 1, so it's radical 1, so it's 1. So at the point 1, I would be at 1, which is interesting because that's what I'm expecting. I kind of want this to go all the way down like that, right? So that's actually looking kind of hopeful. Okay, and then what happens at 0? It would be 2 minus 0, radical 2. Okay, radical 2. Really hard to graph, but I'm going to remind you that it's about 1.4. So that'll be right between 1 and 2, kind of like there. Okay, so that's looking interesting. Suddenly I've got kind of a line that goes up like that. Okay, so now let's look at -1. Now I'm a little nervous about -1, but I'm just going to go ahead and trust the process, because negatives and square roots don't work. And then I'm going to notice that we've got the opposite of x, so change the sign of x. So we're not going to have a problem with the negatives because this is actually going to become 2 plus 1, so it's radical 3. And you're all thinking, oh, great, radical 3, love that. It's about 1.7. So at -1 will be like right there. So it's not much higher. And then if I go to -2, yay, this one's not going to be too bad because that one's going to be radical 2 plus 2, which is radical 4, which is 2. Thank goodness. So at -2, we're going to be up here. And it's hard to tell, and I have violated the cardinal rule of graphing. Maybe it's the ordinal rule. It's one of the rules of graphing that says you should use a graph paper so that you get it. But hopefully you can see this is not in a line. And in fact, whenever we've got a radical, we're expecting that kind of parabola shape. So I'm expecting that it's kind of rounded like that. Kind of rounded. I know that I did just a sorry attempt at rounding, but it's supposed to look kind of curvy like that. So, and then I'm going to break another rule, and I'm going to say sometimes when we're graphing piecewise defined functions, I will go ahead. So this part is all the yellow part, right? This is this half. Sometimes what I will do when no one is looking, so everyone check, is anyone looking? Nobody's looking. Okay. Da-da! What if I looked at 2 from the perspective of what would happen in this land? I know it's strictly less than 2, but let's look at what happens if I plug 2 in. 2 minus 2 gives me radical 0, so this would be 0. So what I would expect is coming in towards 2 in yellow land, I would be coming close to this point. So I'm guessing this will go like that, which is what I'm expecting, right? It's that half a parabola shape that we expect with a square root. And now, why did I do an open circle? I did an open circle because it's not actually defined here. If it were defined here, then we'd have 2 points defined for x equals 2, and then it wouldn't be a function. So we're just kind of sneaking up. We're just saying, well, what if we could do this? And what you could do if you wanted to is we could double check like at 1.5 and at 1.5 or 1.6 or 1.7, we could look at these points in between. For the benefit of not making a 400-minute video, I'm not going to do that. You're going to take my word for it, but we could absolutely check those points, but it will look like that. So visually, does the limit of f of x exist, two-sided limit coming in from both sides, does it exist at x equals 2? And the answer is, I'm guessing no. And let me write in two-sided, because do we have limits? Sure, we have a limit from the right and we have a limit from the left, but it's that situation where they don't agree. They don't poke into the same spot. They come to different spots. So the two-sided limit doesn't exist. That's the graphical analysis. So how can we do this with algebra? So with algebra, again, oops, sorry, let me not get rid of it. We want to look at it from two sides. And here, since we're looking at the limit as x approaches 2, not 0, I'm going to look at the limit as x approaches 2 from the left of f of x. And that would be from the left, from x is smaller than 2, is radical 2 minus x. Okay? And of course I picked the really hard one first. Ugh. So the really hard one, what do we do with it? Well, we've got limit laws. And the first limit law, not the first one, I forget which one it was, but the first limit law we're going to use says that if you've got the limit of a square root or the limit of a radical, you actually have the radical of the limit. So far, so good? Okay. Then as we step through it, I know that one of the limit laws says if we've got the limit of a difference, if we're subtracting 2, we actually take the limit as x approaches 2 from the left of 2, and we subtract the limit as x approaches 2 from the left of x. Okay. Now we're cooking with gas because the limit as x approaches anything of 2 is just 2. And the limit of x as x approaches 2 from the left or the right is going to be 2, which means we've got radical 2 minus 2, which is radical 0, which is 0. That was a bit. That was a lot. I don't know. I think we all deserve, you know, some nice fruit punch or something right now. We should celebrate. Woohoo! My brain says we should celebrate with ice cream, but I can't eat ice cream. So then I would have to say we could celebrate with like oat milk ice cream, but that never sounds like a celebration to me. So I don't know. If you guys want to celebrate with oat milk ice cream, you go for it. That's awesome. But instead, I will celebrate by continuing the problem. I'm going to look at what happens, because what sort of celebration would it be without math? So the limit of the function as x approaches 2 from the right, I should have done this one first because now I'm too tired to finish the problem. But remember that from the right side, from the positive side, we've just got x. So this is just the limit of x as x approaches 2. The limit of x as x approaches 2 from either side is just going to be 2. And then we go, oh, these don't agree. Now keep in mind, there's some subtlety here. Is there a limit? Yes. From the left, the limit is 0. From the right, the limit is 2. We know that. From the right, the limit is 2, right there. From the left, the limit is 0. So we know this from the graph, but this is the algebra side of it. This is the actual proof. So we know that the two-sided limit as x approaches 2 of f of x, what is it? Everyone can say it with me. Does not exist. And we're done. Oh, don't fall down. Woohoo! I know, it was so long, even the paper's too tired to sit still. So hopefully that made sense. If not, ask me lots of questions and, have a great day. If you don't, I hope the day goes fast. And get out, get some sunshine. I'm looking at sunshine right now. I'm a creature of darkness, so of course I avoid the sunshine. But you all should go get some sun, go get some vitamin D, frolic, play, do some art, do something, listen to music, play some video games, whatever it is you do, to recharge, and then come on back and I will be doing yet more math. Woohoo! And, otherwise, math on.